Hello, I am Manish Singh.
Hello, I am Pranshu Gupta, and today in this video we'll be talking about chromatography. So, what is chromatography? Chromatography may be defined as a process of separating a mixture of components into its individual components through equilibrium distribution between two phases. It is an analytical technique commonly used for separating a mixture of chemical substances into its individual components so that the individual components can be thoroughly analyzed. Essentially, the process of chromatography is based on the principle that different components of a mixture travel at different rates through a porous medium under the influence of a solvent or a gas. The process of chromatography involves a sample being dissolved in a mobile phase. Then, the mobile phase is forced through an immobile, immiscible, stationary phase. A component which is very soluble in the stationary phase will take much longer to travel than a component which is not that soluble in the stationary phase but very soluble in the mobile phase. As a result of these differences in mobilities, the sample components will get separated from each other as they travel through the stationary phase.
So, there are many applications of chromatography and it has its uses in various industries. Chromatography plays an important role in many pharmaceutical industries, in chemical industries and also in food industry. Environmental testing laboratory generally want to identify for small quantities of contaminant such as PCBs in waste oil and pesticides. The Environmental Protection Agency makes the method of chromatography to check drinking water and to monitor air quality. Pharmaceutical industries use this method to prepare huge quantities of extremely pure material and also to analyze the purified compound for trace contaminants. The other application of chromatography, especially HPLC, used in protein separation like insulin purification, fractionation, and enzyme purification. Chromatography is used in DNA fingerprinting and bioinformatics.
Now before moving further, let us learn about some terms which are used in chromatography. Mobile phase or carrier. Solvent moving through the column. Stationary phase or adsorbent. Substance that stays fixed inside the column. Eluent. Fluid entering the column. Eluate. Fluid exiting the column. Elution. The process of washing out a compound through a column using a suitable solvent. Analyte. Mixture whose individual components have to be separated and analyzed. Retardation factor. In chromatography, the retardation factor is the fraction of an analyte in the mobile phase of a chromatographic system. In planar chromatography in particular, the retardation factor Rf is defined as the ratio of the distance traveled by the center of a spot to the distance traveled by the solvent front.
The image shown is a sample TLC experiment result. In a TLC, the component that travels the maximum distance is the least polar, and the component which travels the minimum distance is the most polar. In the image, we can see that the solvent front has traveled 5 cm, the B component has traveled a distance of 3 cm, A distance of 2 cm, and C a distance of 1 cm. Since B has traveled the maximum distance, we can say that component B is the least polar and C is the most polar component among these three. The retention factor value is calculated as the distance traveled by the component divided by the distance traveled by the solvent front. So, using this formula, we can calculate the RF values for all the three components. For example, for component C, the distance traveled by the component is 1 cm and the distance traveled by the solvent is 5 cm. Hence, the RF value is 1 by 5, that is 0.2. Similarly, the RF value of A is 2 by 5 and RF value of B is 3 by 5.
Chromatography technique that uses paper sheets or strips as the adsorbent being the stationary phase through which a solution is made to pass is called paper chromatography.
In this experiment, we attempt to separate the different inks in the different color markers used by using paper chromatography. Using a filter paper, we first draw a line of about 1.5 cm above the baseline of the filter paper. using a pencil. Next, we apply small but concentrated amounts of markings on our filter paper. This is to ensure that we have enough components so that even when they get diluted as they go up, we have enough. If the sample spots are too large, it will be difficult to distinguish the individual spots on the chromatogram. The prime advantage of chromatography over other separation techniques is that only a small sample is required. Chromatography can be used to separate small amounts of substance from a mixture based on the different solubilities of the component. To begin, we first add a small amount of a suitable solvent, which is water in our case, in the beaker. The choice of solvent depends upon the type of sample we use in the experiment. In this experiment, we use water-based inks that are soluble in water. Hence, water is a suitable solvent in this experiment. Next, we immerse the chromatography paper in the beaker. We will then cover this beaker with the lid. Covering the beaker with the lid is important in order to minimize the evaporation of the solvent as it travels up in the process. We can see as the solvent moves up the chromatography paper, it carries the different dyes along with it. Dyes which are more soluble in the solvent will migrate faster and further along the chromatography paper. When the solvent front reaches near the top, we will then remove the chromatogram. We will then mark the solvent front with a pencil line. The applied spots will be traveling up the chromatogram relative to the measured solvent front. Knowing the solvent front is important for calculation of RF values. To ensure maximum separation for the spot of the dye for accurate identification. But care has to be taken that the solvent should not overrun. If the solvent front reaches the top of the chromatogram, the actual distance covered by the solvent front could not be determined. Let us now look at the results. We can see that many of the inks are made up of a mixture of dyes, except for the yellow one, because there is only one spot. We can say that the yellow ink is pure as it is only made up of one dye. The black ink is a mixture of three dyes, of which the blue dye is most soluble in solvent as it has traveled the farthest. The blue ink is a mixture of two different dyes, one purple and the other blue, and the purple dye is insoluble in water as it did not migrate and remained at the start line. For the dyes which were not well separated, we can consider doing this experiment with a different solvent. Now let us repeat the experiment, but this time let's draw the start line with ink rather than pencil. We'll again repeat the same steps. We can see from the results that the ink is also soluble in the solvent and move up along with the dyes and hence complicate our results. The start line is drawn with pencil as the pencil line is made up of graphite and is insoluble in the solvent, hence it will not lead to an inaccurate chromatogram. The start line is not drawn with ink as ink will dissolve in the solvent, thus complicating the results and leading to an inaccurate chromatogram. Let us do this experiment one more time, but this time let's see what happens if the ink spots are below the solvent level. We observe that the different inks do not get carried up the paper but instead dissolve in the solvent. The inks cannot be separated. We should ensure that the sample spots are above the solvent level in order to prevent the sample from dissolving in the solvent before it is carried up the chromatography paper. This prevents the separation of components of the mixture.
We'll discuss about the column chromatography. Column chromatography is a technique which is used to separate a single chemical compound from a mixture dissolved in a fluid. It separates substances based on differential adsorption of compound to the adsorbent, as the compound move through the column at different rates which allow them to get separated in fractions.
In column chromatography, first we need to prepare a column. To do this, we keep a cotton at the bottom of a clean and dry glass column. Now on this, a thin layer of acid washed sand is kept to support the column. The stationary phase, which could be alumina, silica gel or starch, mixed with a non-polar solvent such as hexane is then placed. Now again a thin layer of acid washed sand is kept on the stationary phase. The mixture to be separated is now dissolved in a highly polar solvent which could be for example alcohol and is introduced into the column. After some time, the component of the mixture separate and form thin bands. The component that is more weakly adsorbed will move faster through the column and therefore will get separated first. And the component which is most strongly adsorbed will get deseparated the last.
Thin layer chromatography or TLC is a chromatography technique used to separate non-volatile mixtures. Thin layer chromatography is performed on a sheet of glass, plastic or aluminum foil, which is coated with a thin layer of adsorbent material, usually silica gel, aluminum oxide or cellulose.
In the TLC technique, first we spot the mixture on the starting line on the TLC plate. Then we put the TLC plate in the jar containing the mobile phase and cover it with a lid. We can see that the mobile phase is moving upwards to the stationary phase particles. Due to the action of capillary, there are tiny spaces between the particle of the stationary phase. We can see that the major components of the mixture are separated and form several different spots due to different travel distances in the stationary phase. Let us look at one more example of thin layer chromatography. We will talk about fluorescent compounds. The experiment is done under UV light. The first spot on the right is a mixture of unknown compounds and the remaining three spots are pure compounds. Using TLC we were able to see the number of components in the mixture. Roughly we can see three different spots on the TLC plate.
Gas chromatography is a common type of chromatography used in analytical chemistry for separating and analyzing compounds that can be vaporized without decomposition. Ion chromatography separates ions and polar molecules based on their affinity to the ion exchanger. It works on almost any kind of charged molecule, including large protein, small nucleotides, and amino acids.